Kirchhoff's law. Our question here says, use Kirchhoff's law to find the value of I in the figure below. And for Kirchhoff's law, we have two basic laws. We have Kirchhoff's loop law, and then we have Kirchhoff's node law. We have the loop law, Kirchhoff's loop law, which is the loop law, and then we have Kirchhoff's nodal law. Our Kirchhoff loop law says that the algebraic sum of voltages in a closed loop is equal to 0. The algebraic sum of voltages in a closed loop is equal to 0. So let us look at this diagram. We have two loops there. We can see one loop, and we can see let me call that loop V1. So the algebraic sum of voltage drop across this loop is equal to 0. And then the algebraic sum of the second loop there, the algebraic sum of voltages in this second loop is equal to 0. That is Kirchhoff loop's law. And the loop law refers, as we have just defined it, it refers to voltages. While the nodal law, the Kirchhoff nodal law relates to currents. It relates to currents. And Kirchhoff's nodal law states that the algebraic sum of currents in a node is equal to 0. The algebraic sum of currents in a node is equal to 0. So we have this node there, and then we have the current I1 entering there. When the current enters a node, there would be a split. So I1 gets into this node, and then it splits into, say, I2 going down, and then I3 going here. So what that invariably means is that I1 is minus I2. Let me call this one I1. I1 minus I2 minus I3 is equal to 0. Or we can say I1 is equal to I2 plus I3. So the algebraic sum of currents in a node is equal to 0. That is Kirchhoff nodal law. Loop law relates to voltages, and nodal law relates to currents. So I'm going to be solving this question using nodal law. Then I'll come back and solve the same question using the loop law. I'll solve this question now using the nodal law. Then I'll come back to solve it using Kirchhoff's loop law. So if we look at this diagram, if we look at the diagram properly, we'll see that we have one node. This diagram has one node, and that is our node here. So according to the law, when current gets to this node, it splits into two, one coming down here and then one going this way. Let me call the one coming down here I1, and let me call the one going the other way I2. So based on that, I can say that I is equal to I1 plus I2. I is equal to I1 plus I2. Now, looking at this diagram, I can see a 0.4 ohm internal resistance of the battery. I can bring the 0.4 ohms up here so that it becomes in series with my 5 ohm resistor. So I can add those two in series. If I add those two in series, 0.4 plus 0.5, it gives me an equivalent. It gives me an equivalent of 5.4 ohms. Also, if we look at this diagram, we have a node here. Let me say that we have 30 volts coming all the way here. When it comes across this resistor, the 5 ohm resistor, or as it were now combined 5.4 ohm resistor, there will be a voltage drop across that arm, across this whole arm. There will be a voltage drop. Then the voltage gets to this node. Let's call the voltage that gets to this node V1, for instance. And remember, according to parallel connection, we say that whenever we have a parallel connection, the same voltage will flow across the resistors connected in parallel. the same voltage flows across the resistors connected in parallel, meaning that V1 will flow across the 7 ohm resistor, and then V1 will also flow across the 3 ohms resistor. So if we are going to solve this now, remember I said there will be a voltage drop across this arm. There will be a voltage drop across this arm that we've circled here. Now, I1, we've already established that I is equal to I1 plus I2. What is I? Based on the diagram, we can say that I is the voltage drop across this arm. And what is the voltage drop across that arm? The voltage drop across that arm is going to be 30 minus V1. That is our voltage drop across the arm. And the formula for finding, remember that the formula for finding current is equal to V over R. So therefore, the current across this arm, I, is equal to 30 minus V over the equivalent resistance on that arm, which is 5.4. So I now is equal to, based on the equation written up there, I is equal to I1 plus I2. What is I1? I1 in this case is equal to the current drop across the 7 ohm resistor, which is equal to the voltage on that node, V1, over the resistance on that node, over 7. And then, what is I2? So, plus I2. I2 will be the voltage drop across that node over the resistance on that node, which is V1 over 3. So that gives us this expression, or this equation gives us the same equation as what we've written here, equation 1 above. Let's call this one equation 2. So this equation is the same thing with equation 1. We just related it in terms of voltages. So across the battery and the node, and then I1 is the current on the node across the 7 ohm resistor, and then I2 is the current across the 3 ohms resistor. That's done. We can resolve this to have that. Let me get what's the LCM of 7 and 3 is 21. So I have that 30 minus V1 over 5.4 is equal to I take my LCM 21. 7 going to 21 3 times. 3 times V1 will give me 3V1 plus 7. 3 into 21 is 7. 7 times V1 will give me 7V1. So with that done, this is going to be equal to 10V1 over 21. With that done now, I can cross multiply, take this 5.4 up, and then multiply this by this. So I get 21 into bracket 30 minus V1 is equal to 54 V1, and this will give me 630 minus 21 V1 is equal to 54 V1. So that I can say that 21 plus, if I take this 21 minus 21 over here, it becomes positive. So I have 75 V1 is equal to 630, and then V1 would be equal to 630 divided by 75, and that will be equal to, V1 is going to be equal to 630 over 75, and that is 8.4 volts. So remember that from our equation, we said that from equation 1 or from equation 2, we said that I is equal to, if we relate equation 1 to equation 2, I is equal to 30 minus V1 over 5.4, which is the voltage drop across that arm we circled there. So we can put V1 into that equation, and then we have that I will be equal to 30 minus 8.4 over 5.4. So that I will be equal to 30 minus 8.4 would give us 30 minus 8.4 will give us 21.6 over 5.4. And if we use our calculator to resolve that, we'll get that I is equal to 4 amps. That is using Kirchhoff's Nodal